We're now going to look at the reactions of the group 2 elements with water. So just like the group 1 elements, the metal, which I'm going to use an M for, is going to react with water to form the metal hydroxide. Now, because these are in group 2 and a hydroxide is a 1- ion, then the formula would be the formula of the metal and then 2 hydroxides. And just like group 1, they're going to produce hydrogen gas. So if we balance that equation, we need to put a 2 in front of the water. So they're all going to do this. We're going to have a solid metal, liquid water, and we're going to get hydrogen gas. The state symbol for the metal hydroxide will depend on which metal hydroxide it is because they have different solubilities. They are all alkaline solutions, so we're going to form an alkaline solution. The pH is going to be above 8 at the end. So let's start with magnesium. And if we write our equation, we've got Mg solid, so the M has become Mg, and 2H2O liquid. And that's going to give us magnesium hydroxide. And this one, I'm going to change colour because this is the sort of special one. This is going to be a solid because magnesium hydroxide is sparingly soluble. That means not soluble really at all. So we're going to say sparingly soluble. So what we'll see is, because this reaction is incredibly slow, rather than seeing effervescence, we're going to see a few bubbles on the surface of the magnesium. I'm going to miss out steam for now because that's kind of an extra reaction that we're going to need to sort of highlight of magnesium, and we're going to continue with the reactions of the metals with water, and we'll come back to that magnesium. So what about calcium? Well, we're going to react the calcium with water in the exact same way that we did the magnesium. And this time we're going to make calcium hydroxide and hydrogen. And the calcium hydroxide is more soluble than the magnesium, and so we're going to give an AQ state symbol. This is also a much faster reaction, so we will see plenty of fizzing, some effervescence due to the hydrogen gas, and some white solid of calcium hydroxide, as it is slightly soluble. What that means is some calcium hydroxide dissolves to give an alkaline solution. So something with a pH greater than 7. And then if we move on to strontium, then it's going to also fizz because remember, we're getting that same reaction. And we're going to have strontium hydroxide is more soluble than calcium hydroxide, and so we'll barely see any solid. In fact, it will mostly be a solution. So our strontium reacts with our water, same reaction, to give us the strontium hydroxide and hydrogen gas, our effervescence. And then our last one, barium. Again, we can do the equation first. Barium plus water goes to barium hydroxide and hydrogen. And again, we'll see effervescence and the barium metal disappears. It's reacting with the water to form a colourless solution. Very soluble. So if I just put barium hydroxide is soluble. Okay. So the general reactivity of the group 2 elements with water, we noticed that we were very slow and then we gradually got faster. They increase as you go down the group. As you go down the group, there are more shells and more shielding. So the nuclear attraction to the outer electrons is less, and the outer shell electrons are more easily lost. And then it asks us to look at what's happening to the oxidation states. So if we rewrite the equation, the general one, with just an M in there, and we look at the elements individually, and if we change colour pen, we can see that the metal is 0 at the beginning, and then it's +2 in the hydroxide, because each hydroxide ion is -1. So the metal is oxidized as its oxidation state increases from 0 to +2. So who's reduced then? If somebody's oxidized, somebody else must be reduced. And if we look, we've got hydrogen as an element at the end, and in this water it's +1. So hydrogen is reduced as its oxidation state decreases +1 to 0. Remember I said we were going to go back and look at that special case. So again, I'm going to change colour of pen. I'm going to go back and look at that special case of what happens if we put magnesium, rather than in water, in steam. So I'm just going to draw a special box around this. This is something different. Magnesium barely reacts with cold water. So what happens when we put it in steam? So what happens when we put it in steam is a completely different reaction. We see a bright white light and a white solid forms. So remember, there's no liquid here because steam is a gas, so steam is H2O gas. So there's no liquid. So we take our Mg solid and we add in H2O gas. And the white solid that we get is not the hydroxide, rather it's the oxide, and then we get some hydrogen gas. And if we check the balancing, we can see that that's already balanced. But when we react magnesium with steam, we get a different reaction to the reactions with cold water.